An AI agent that talks to you on Telegram, writes and edits real files on a real machine, and still remembers who you are months later. How does something like that actually work under the hood? Over the next 20 parts, we're going to find out by reading the real, open source code. Welcome to part 1 of a 20-part deep dive into Hermes Agent, a real, open source AI agent built by Nous Research. Every other AI agent video we've made on this channel used original example code we wrote ourselves. This series is different. Every file, every line number, every snippet you'll see is copied straight from the actual public repository, pinned to one exact release so nothing drifts as we go. Nothing here is reconstructed from memory or made up to sound plausible. If you want to follow along, the repository link is in the description. Here's the shape of what's ahead, across 20 parts total. We'll open the agent loop, the core object that drives every single conversation. We'll cover prompt assembly, context compression, and caching. We'll spend real time on how one agent talks to 18 or more model providers through a single interface. We'll go deep on the tool system, the registry, the 6 sandboxes tools actually run in, and a good number of the 77 tools registered right now. We'll cover session storage, memory, and the self-improving skill loop that's genuinely the most distinctive thing about this project. We'll open the messaging gateway that lets one agent live on Telegram, Discord, Slack, and more at once. And we'll close out with cron jobs, the plugin system, and how Hermes shows up directly inside an editor like VS Code or Zed. 20 parts, 1 repository, real code the whole way. So what is Hermes Agent, concretely? It's one Python agent core that gets reused everywhere. The same class drives a terminal conversation, a Telegram reply, and an unattended cron job. It's self-improving. After a complex task it can write itself a reusable skill, and that skill gets refined the next time it's used, rather than the agent relearning the same thing from scratch every session. It lives wherever you already are: Telegram, Discord, Slack, WhatsApp, Signal, and a plain command line, all served from one long-running gateway process. It can execute commands in 6 different kinds of sandboxes, from your local machine to a disposable cloud container. And the whole thing is MIT licensed, so every claim in this series is something you can go verify yourself tonight. Here's the shape of the whole system, straight from the project's own architecture documentation. 3 entry points, the command line, the messaging gateway, and cron or batch jobs all construct the same class, AI agent. That one object owns prompt building, provider resolution, and tool dispatch. And everything it does gets written to 2 places: session storage, a real database on disk, and the tool backends that actually execute commands, browse the web, or call other services. 3 doors in, 1 core, 2 places the results land. Every part of this series is a closer look at one box or one arrow in this exact picture. This is a real listing from the repository, not a mock-up. We're highlighting the folders this series actually walks through. Agent holds the conversation internals, prompt building, compression, memory. Gateway is the messaging layer. Hermes_CLI is the terminal interface and setup wizard. Tools is the registry of everything the agent can actually do. Cron is the scheduler. Plugins, skills, and optional skills are how the agent gets extended without touching its core. And tests, at this snapshot, a suite of roughly 25,000 tests, is how a change this size stays safe to ship every week. This is the actual class, verbatim from run_agent.py, starting at line 403. Shown lines are exact, with both the docstring and the 40+ parameter list marked exactly where we cut them for screen space. Its own docstring says it plainly. It manages the conversation flow, tool execution, and response handling. The constructor opens with a provider and an API mode, then continues for another 3 dozen or so parameters we don't have room to show, among them a model name, a cap on tool calling iterations, and lists of toolsets to enable or disable. Every entry point we just saw, the command line, the gateway, cron, ends up building one of these. Everything else in this series is really just answering one question: what happens after this object gets created? Here's something you would only catch by actually reading the code. Run_conversation, the method you'd expect to hold the entire agent loop, is only 11 lines. Its own comment says it plainly: forwarder. The real work lives in a completely different file, agent/conversation_loop.py, in a function of the same name starting at line 518. That's a deliberate pattern in this codebase. Run_agent.py stays as a stable public interface, while the 5,000-line implementation behind it can be reorganized freely. We'll open that real loop in part 2. A few honest numbers, counted directly from the pinned commit rather than copied from a marketing page. 77 tools are actually registered in the Tools folder right now. They're organized into 57 toolsets, fine-grained groupings so a deployment can turn capabilities on or off in bundles. 6 terminal backends let a command run locally, in Docker, over SSH, or in a disposable cloud sandbox. And the Gateways Platforms folder holds files for around 20 messaging surfaces. This project moves fast. Between the previous release and this one, it took in over 1,700 commits, so we're citing exact numbers at one commit specifically so they stay correct for the whole series. The project's own developer documentation lays out design principles like these, and they explain a lot of what we just saw. Prompt stability: the system prompt doesn't mutate mid-conversation, which is what makes the earlier forwarder pattern safe to refactor. Observable execution: every tool call has to be visible to the user, not run silently in the background. Interruptible: a running API call or tool can be cancelled by new input at any point. One platform-agnostic AIAgent class serves the command line, the gateway, cron, and batch jobs alike, instead of 4 separate implementations. And loose coupling: optional pieces like plugins and memory providers hook in through registries, so removing one never breaks the core. And here's how a tool actually joins the system: 2 of the 77, verbatim from tools/file_tools.p.y at line 2014. Each call to registry.register at the top level of the file is how a tool announces itself: a name, a toolset it belongs to, a schema the model sees, and a handler function that runs when it's called. Tools/registry.p.y itself imports nothing from these tool files, it just waits to be called. Every tool file imports the registry and registers into it at import time. That's the whole mechanism, no manual list to maintain anywhere, which is exactly what the project's own comments claim, and exactly what we just watched happen in the code. That's the map of Hermes Agent, straight from its own real, pin source. 1 class, 3 entry points, a tool registry with 77 real tools, and design principles that actually hold up when you read the code behind them. Next week in part 2, we open agent/conversation_loop.p.y for real, and trace exactly what happens between a user's message and the agent's reply. The repository link and the exact commit we used are in the description. Subscribe so part 2 lands in your feed, and I'll see you there.